Okay, let's go over the first practice problem. So we have a first order reaction that gives a first order ODE. If we solve the system analytically, this is a separable first order ODE. You'll get the result of CA0 times e to the minus KT. So if I write this down in code, this should be analytic is equal to a lambda function t CA naught times e raised to negative k times t. Let's solve it with SciPy. So we have the initial condition Ca0 is 4 molars, and the reaction time is 15 minutes. So the starting time T minimum is 0, and the maximum time of the reaction is 15 minutes. We didn't specify the time step or the number of time points we need. So we can choose something that's reasonable. Say, let's say dt is 0.01. And the rate constant k is 0.36. So I have, this is the constant, we have the initial condition, and we have the time. And we can define time using NP range from T minimum to T maximum. and the step size. Now plus a dt divided by 2 to include the last point. Oh, numpy. Okay, so this is starting from 0, ending at 15. And then we can solve it using solve IVP. So the first argument is the ODE. So the ODE we define it as dCA dt is lambda function of the independent variable t and the dependent variable CA. And on the right, we have minus k times CA. So the first argument is the ODE function. So that's dCA dt. The second argument is the bounds of t. So that will be here. So if I have a t, we can define a t length as the length of t. And we can also define the t boundaries as the 0th argument of t, comma, the -1 argument of t. So if we evaluate t bounds, it's starting from 0, ending at 15. So we have the t bounds here. And then the third argument is the initial condition in the list. So here we have the initial condition as a number, so we can define initial condition that we feed in as a list of the initial condition, CA naught. So we have initial condition here. And the fourth one is the evaluation of the t. If you run that, we have the solver successfully reached to the end of the integration interval. And what we care is the y, and y is the final result. And if we do .y, we can access the result. And this is a 2D array because look at these two brackets. So it's one row and a lot of columns, and each column corresponds to a time point. And we want to access the first column, so we do index 0. So note that here we only have one bracket versus before we have 2. So we can assign this to our CA as a SciPy solution. And if we want to plot it, fig x subplots. And we can plot the t versus CA SciPy. We label it this. So we see that it is an exponential decay, which is expected. Okay, and then we can also plot the analytic solution. So we still have t and then CA analytic, which is a function, and evaluate it at t. So it overlaps. So let's make it a dashed line. So we can see that they are exactly on top of each other. And we want to solve it with forward Euler's method. Then we need to have a CA forward. So we first establish an empty list. So NP zeros of t length. This is all zeros. And then we want to assign the first number as the initial condition. So define the 0th index as the initial condition CA naught. And if we print that again, the first one becomes 4. And then we can start forward Euler's method for I in range of the t length. We want to assign CA forward I plus 1 to be CA forward of I, the current time step, plus its derivative, dCA dt, evaluated at, it has 2 arguments, the independent variable t, so we have t of I, and then the dependent variable CA, in this case it's CA forward of I, times the time step dt. If you run this, you should recognize from midterm that this will give an index error because we have an extra, we are asking for I plus 1, but we're going out of bound of the length. So we should -1 here so that we get a final answer for CA forward. And we can plot this with CA forward and label it with forward Euler. Okay. And because the time step we chosen is small enough, we see that it has a very high accuracy. Plot the solution curves. Okay. Any questions on this problem? Okay, I think this covers lab 4. Okay, the next question asks you to solve a coupled system of ODEs, also using solve IVP. Let's come back in 15 minutes.
Should be analytical. Differentiate. I don't understand the differentiate.
Because CA analytic here you define as a lambda function, right? Because it's a function, you need to evaluate the function. So you want it here instead of CA analytic, you want CA analytic parentheses T. So
Parentheses or square brackets.
parentheses. Parentheses means because this is a function.
Evaluate.
Evaluate and T.
Okay. Okay. Those brackets, I got my sci-fi on the right, but there's something with my forward. I don't know.
Because you can see it, or
Yeah, like it was popping up and then I closed, for this C2M variable. I put in like the, and it's fine, and that's like me physically.
I think it's fine, but it's covering up because they are very similar. So because 4 is the first one being plotted and the other one are obscuring. So if you comment out these two, yeah, it's still there. It's just that if you layer up the sci-fi solution, it's exactly the same as it. So it covers enough.
Supposed to be the same one?
Because we have a step size that's very small, so it's very accurate. So it's approximate to the SciPy analytic solution. But if you try to make it big, then it will be different. Oh, I guess not. One. Yeah, if it's large enough, you'll see it. But if it's small, it just covers.
Thank you.
You guys can raise your hands. I'll come to you.
I don't know how big. Yeah. We can solve this like in one day, but this one depends on the things and then this one the one we found before. So I don't know how to integrate like. It's
You should want to interpret, you use the self-titled message.
yeah, like yes.
Thanks.
If you invent it, yes, you have to.
What percentage is
Because
because I just want to like the value CA and B. CB because of the lines. So yeah. I don't know. And CB, and the CA values from
this is a couple of systems.
yeah.
So you define ODEs system. The individual CA.
Oh, so you need the value system? Okay.
So you have one solid people. Then within the first function, you have ODE system.
And how do we define small man class? Is it matrix?
Perfect. Or again,
They'll be like,
go back to that's not all.
I didn't think about it. They don't even have any like so it's not. Okay, so it's kind of create something that gives us any. When it does, yeah, it's not.
It's like I'm on.
So when signing your individual assignments, you want it to be these kind of team. All the people with other assignments. CBE.
This. But more this fixed income.
Exactly. Because you have a team three team size C, but size Z only has so E, so then D C D T.
This. Yeah.
This means that we have a
There's
team.
two options.
And then star V we have back.
Mhm.
We have X two C and C B.
Okay. Oh, you can choose B.
So the all the Z star Z comes from the neutral.
Mhm.
So that should see it.
Okay, so is this one? Is this?
We can find to see this. It's up there. Okay. It is actually so for the set is so it's education. So
How do we get the second message?
so you don't use the words.
Or the dot one order?
The access value to the dot.
Oh, yeah, inside that. Oh,
So this gives you.
okay. This is what I'm going to pass. Okay, so it's just this.
Yeah, that's recently setting zero myself.
And so here for the argument max of this. Wait, you guys have asked, even if they ask for the concentration of the mass.
Because that is the, or you can assign it as a variable.
Okay, thank you.
Okay, let's go over practice 2. So this problem, we are solving a coupled system of ODEs using solve IVP. So we have solve the concentration over time for 8 hours. So the beginning time is 0, the ending time is 8. and we are told the length of T, we have 1,000 points. Because we know the number of points, we can use NP Lin space. So from T minimum to T maximum of T length number of points, T is equal to that. Okay, and we can verify the last number should be 8. And then the boundaries of the T is T of 0 and then T of -1. We can print it to verify. It's from 0 to 8. Then we can define the initial concentrations. CA naught is 10. But there are also hidden initial conditions because we have 3 ODEs, we must have 3 initial conditions. So this is initial condition 1. The other initial conditions are CB0 and then CC0. It's not explicitly given, but you should be able to infer that A is a reactant. It has some starting concentration. B and C are products. So initially, there are no products in the reactor. So the initial concentrations will be 0. And the rate constant is given as K1 is 0.92 and K2 is 0.08. Okay, and then we want to define the ODE system. So because this is a system of ODEs, they're all coupled together. So we want to define a system instead of using solve-IVP 3 different times. So the ODE system, we can define it as a lambda function. The lambda function takes in an independent variable t, and then a list of dependent variables z. And then we have a list. And within that list, we have dCA dt, and then we have dCB dt and dCC dt. And then evaluate it with some argument. So CB and CC. We'll come back to those. But let's define dCA, dCB, and dCC dt individually first. They should all be lambda functions. Never define them as list. Define them as functions. And then the independent variable t, and then all the dependent variables. So CA, CB, and then CC. Even though some of them are not used. For example, in the first equation, T, CB, and CC are not used. We still need them for the solve-IVP function. So let's fill them out. So dCA dt is equal to minus K1 times CA. dCB dt is equal to 2 times K1 times CA minus K2 times CB squared. And dCC dt is 0.5 times K2 times CB squared. So we have defined each individual function, but for the ODE system, we want to put in the arguments. The arguments should be the independent variable t, and then followed by z, which is a list of dependent variables CA, CB, and CC. We can use the unpacking parameter star of z. So this is equivalent to, if I write z of 0, z of 1, and then z of 2. So these two are equivalent. Okay, so we define time, the initial condition, and the ODE. So we can now start to solve the ODE. So we have solve-IVP. The first argument is the system of ODEs. The second argument is the boundaries of T. And the third argument is initial conditions. So the initial condition should be a list, and it should be equal to CA naught, CB naught, and then CC. And then the fourth argument is the T eval, and it should be equal to T that we define. If you look at the result, it gives the solver successfully reached the end. So this is a dictionary, and to access different things, we use the keys. For example, if I want to access the message, we do .message. Okay, but what we are truly interested in is the Y argument. So the Y argument here is an array with 3 rows and many different columns. Okay, 3 rows and lots of different columns. If I do shape, 3 rows and 1,000 columns. And the 1,000 corresponds to 1,000 time points. And the 3 corresponds to 3 solutions, each solving for CA, CB, and then CC in this order. So I will assign this as ODE solution. And another way to unpack this is that because it has 3 rows, so you can index 0, index 1, and then index 2. A convenient way in Python to unpack this is to just CA, comma, CB, comma, CC. And you can assign them as ODE solution of 0, ODE solution of 1, and ODE solution of 2. 0, 1, 2, yes. So this is equivalent to CA is equal to ODE solution 0, CB is ODE solution 1, and CC is ODE solution 2. Okay, and we can plot these. Fig x is equal to x plot t comma CA, and then label it as CA. So we see that the reactant decays exponentially. And let's plot CB and CC. So what we found is that CB, the intermediate product, increases to a maximum and then slowly decays. And the product, final product CC, increases to a plateau. I think this concludes problem A. Any questions? Problem B, determine the maximum concentration of B. So here we have already concentration of B stored in CB. And we want to find the maximum point of this. What we can use is np.max. For example, let's try an array of 5, 4, 3, 2, 1. The maximum should be 5. And similarly, we can do it with CB. So np max of CB is 8.85. So the maximum concentration is 8.85 molars. In part C, determine the time at which the concentration of B attains the maximum. So here we want to use argument maximum because let's first see what it does. So let's also try 5, 4, 3, 2, 1. This function finds the maximum and then finds its index. So here in this list, the index of the maximum 5 is at index 0. So this should return 0. So if I place another maximum 6 here, it should be index 0, 1, 2, 3. Should return 3. Okay. And then because we know that the time and CB are paired together, so if I find the argument maximum of CB, it will give us the index at which it attains the maximum. And we can use that index to index the time. So we index using time here. So we found that the time at which it attains the maximum is 1.17 hours, I think. Okay, any questions on these? Okay, now you can try solving this second order ODE, which has conveniently transformed for you to a system of first order ODEs and plotting the phase portrait.
Start facing out. I think. We can solve.
Yeah.
So I still haven't predicted. I can go back.
So the maximum square is zero. This is all.
This one for the third question. I tried to use like a lab setting. I come up with what I'm doing. They keep telling me, I don't know what's wrong.
So you have the length of t, which is a lot, right?
Yeah.
And it's assigned to I, but you only have two indices, and you're using x, not x, it's one. So
I'm just using it X.
So you define it as x equals 1.
So should we have some,
And then
should be between 0 and 1.
so what is the I think you need the
I just use
Only.
like more less.
this is for
So I don't need the follow.
in the last lab we need
Yeah.
for loop because we have
So many.
different hems,
Okay. So I don't need the for loop.
not for problem
So
3.
they don't need to be indented.
So for problem 4 you don't need a for loop, but not
Okay.
this problem.
And then sure. Okay. Oh, sure. Yeah. Thank you.
Yeah, this is what I just feel. Oh, yeah, so. This one should be that I can. Yeah, this is what I think. This is your. But it's not an item.
I was thinking about
It's your system. But it's like.
Decoration operations.
So I think you define beta
Basic. There's so one is.
please say that. So even when you
So you can say I that but more time I think inside like so that makes sense that I'll show us calibrate suicide so I see so for example I will have some that I will obviously want to select 2t and negative equal t of 1 there's a lot to you just have so English is just give you you have to feel and then you the whole solution factor
You want
that's wrong.
You want to decorate. Something like no, but arcade like that's a. No.
I think we don't know. I need to I was wondering if it found this autism.
You make those dirt round, you put Oreos on. They're not. That's pretty much.
But this is your solution.
That's so beautiful.
Oh, so you basically just replace
That's okay, we can have. No, is there? I like you walk around. For the fixing my bones. Oh, that's what it is, okay, yeah. That makes sense. Yeah.
How did you get your muscle? How did you get your muscle?
Copy that plus. Okay, let's look at problem 3, linear pendulum. So we have a second order ODE, and the problem already broke it down into a system of first order ODE. I could ask this on an exam to let it break it down for me. Okay, this is fair. And then to solve a system using solve IVP. So the time, this should be quite routine. So minimum, maximum, dt, and then use NP arrange from minimum to maximum of dt. And I do a plus dt divided by 2 and assign it to t. So beginning is 0, ending at 1. So the t length is the length of t. And then t bounds is t of 0 and then t of -1. From 0 to 10. And then the initial condition is omega theta 0 is 0. Omega 0 is 0.5. So we have a list of initial conditions, which are theta 0 and omega 0. The order matters. And then we can define the system. So the system, we have ODE system as a lambda function, independent variable t, a list of dependent variables z. And within the list, we have d theta dt, and then d omega dt. And we want to define those. So d theta dt and then d omega dt. They should all be lambda functions with independent variable t and then dependent variable theta and omega. So d theta dt is equal to omega. And d omega dt is minus g divided by L times theta. And then G and L, I think, is defined above. G is equal to 9.8 and L is equal to 1. And then I think we can now solve the ODE of solve IVP. Oh, here, we haven't finished this. So after we define d theta dt and d omega dt, we want to put in the arguments. The arguments should be independent variable t, and then unpack all the dependent variables z. And so we input this ODE system into solve IVP, the boundaries of t, the initial conditions we defined earlier, and t evaluating at all the t's. And what we really care about is y. So we retrieve y by using dot y. It has 2 rows. Each row represents theta and omega. And it has 2001 points, representing 2001 time points that we defined here. So I can unpack the result. So I'll store the result as ODE solution. And I again can demonstrate the unpacking syntax as theta comma omega is equal to ODE solution. So theta will be ODE solution of 0, and omega will be ODE solution of 1. So this is equivalent to theta is equal to ODE solution of 0, and then omega is ODE solution of 1. And I can plot. So the second part B is plotting the solution over time in a 2x1 grid. Subplots. Okay, so here I have a grid. So for axes of 0, I want to plot t and theta. Axis of 1, I plot t and omega of 1. And I can change the color or to whatever you want. The top is theta over t, and then the bottom is omega over t. You should label the graph and then give them some legend. But I'll move on to part C, which is the phase portrait. So phase portrait, instead of having x-axis as t, the x-axis becomes theta, and the y-axis is omega. So we only need one figure. Subplot. Okay, so axes plot theta and omega. So that's our trajectory. Let's make it color black. And then you see that the width length here is weird. So let's set the aspect ratio as 1 and also set the box aspect ratio to 1 for better interpretation. So now it's uniform. To plot the initial point, we can use the trajectory, but plot the 0th point, so the initial point of the trajectory, and make it a dot. So if I don't do a dot, you see nothing has changed because it's a very tiny dot. If I make it bigger, you'll see that it starts here. And then the final point, we can do the same thing, but now we index at -1. So that's the ending point. Then let's change it to a big cross and then color red. So after some time, it ends up here. And then we also want to plot the slope field. To plot the slope field, we want to initialize all the vectors. So I think here we want a vector of 20 equidistant arrows. So we can do theta vector is equal to NP lin space from, I made a typo, it should be -0.7 to 0.7 with 20 equidistant points. And then we have the same as with omega. So we define the vectors, but we actually want is the grid of points. So we use np.meshGrid of theta vector and then omega vector. So this should give us 2 arrays. So we can unpack them as theta, big theta, and then big omega. Okay, I'll copy these down. So with the slope field, I will use x.quiver. The first argument is the x-axis. Second argument is the y-axis, omega. And then the third argument is the x component of the slope. And the slope is d theta dt. And d theta dt takes in 3 arguments, t, theta, and omega. So I'll input t, big theta, and then big omega. Now I'll do the same with the omega. And these are the slope fields. They're a little hard to see, so I'll define the magnitude, so the length of the slope, which is calculated by distance formula, the square root of the x component squared plus the y component squared. And then I'll divide the x and y component by the magnitude. So now they have the same length. With the fifth argument, I'll put in magnitude, which corresponds to the colors. So now they have different colors. And I'll type in the settings provided in the prompt. It should make it look better, I hope. Okay, now you can see the slope field. Then you can do some additional settings like set the x limit to -7 to 7. Do the same with y. Oh, it's -0.7 to 7. Okay, and that should conclude this problem. Any questions? Okay, you can try problem 4, which is very similar, but now you have different initial conditions that you will need to use a for loop. Now we'll come back in at 150. But before that, I want to emphasize that please do try these problems, because these problems are representative of the problems that you could see on a midterm. So please do these and then ask questions if you have. Yeah.
Thank you. I think that's easy. You can buy it from the outside. You can draw the table right. Just don't. It's a nice question. So I think this is. We could buy 1 month and then everything becomes. Like you're, yeah, exactly.
Science.
No, exactly. No one get that because I don't want to feel like that. You're not doing it. Yes.
I don't know how to go about this.
We buy cookies. But you're yeah, those can get us. Just the refrigerator. They're going to. Yeah. Isn't here decorating it? What time should it be?
I usually don't do anything until like is any seems to be that like volume responsibility. Some of because I was very well, no, we feel each other before. I don't.
No, I'm involved in the traction. Yeah, I think that's really good.
She has 67.
Really? I hope you have like best.
I see that.
Yeah. You can put my reviews. I have my mom, I have my brother, I have my friends. But I got my friends and everything. Oh, she said downtown first. Oh. She got a ballet thing.
Oh, the last day.
And then it's
I only see where my some of it is.
I see why. Not
Sure, you have the.
She doesn't want.
It doesn't matter. I can just handle it.
Oh, fine. Oh, that's it.
No, that's what I told you. Yeah, so you have That's from.
So if you feel like you're. The very next problem when you're given a set of initial conditions. And so I created two arrays and then I looked at the previous one and I don't know if this is just for the arrays. I don't know how to combine. Yeah.
Trying to start all day.
Yeah, I just did it so it's funny. It's right. Well, it's like years.
Yeah, people buy it's like.
I don't see.
One by one.
Oh, I should go one by one.
Because I mean, like you want one of the software.
So it's just like the I saw the picture.
So you. And you just like solve that. But if you wanna do that, how do you pass that into?
She's yeah.
So that means we have to make it that we solve it, then we have one soup and so we should indicate the principle.
I checked.
Oh, yeah, then what's the German? That's not.
Yeah, this country next year.
It's like example.
Well,
But isn't that a little? We have like the. Yeah, it's very for this one. They don't know.
And then they can also look like a nurse because the girl can speak like a shark. It's option and it's like, and then you try to it's the person look like they're like a little more.
Oh.
And you have. Oh, I didn't combine it together. Okay. Now. Thank you. You wanna.
And my idea of showing and set up the blush like that. Oh, you were right. Once I try a lot of though, I got a dimensional.
should get that. Not this.
Do you miss how long it's done?
Oh, it's
Next one,
10.
2002. So what is?
Wait, do you have most of it? I feel like that's wrong.
I love it.
I want people to ask me what that sounds like. Yeah. And a matching shirt and a skirt.
Like they will go with the old ass.
It's the same thing.
So you know when we were making the episode, and she was telling me about the
Okay. I see.
So you were down.
Yeah.
That's all we got. It's kind of hard.
No, but so, lawyer,
Right? I literally have in mind.
You know, there's.
yeah, he's all on his line.
So we want to.
When my cousin got married, I another.
Your math?
Perhaps like. You know what it was? What?
You find one big.
They didn't have like.
You find everything.
No, right on that.
So the party starts at
You would want
6.
to.
We don't eat
This-
until
Having
You go to like.
we have to wait in line to take the trip with them. It's like this like wake up with them. I wanted to.
Here's the and of other people. I'm confused on but everybody's confused on one.
All the.
See, look, we have to like take pictures.
because
Yeah,
you're
the laws.
2 months.
And then there's.
And it really says that everybody is gonna stay the same. For the rest of the semester.
He's
So I'm really only pushing about like.
Do you know, that was about, that it was a bet that they made when they were younger, like if we.
This will be
28.
played out.
These usually do 5 p.m.
Then
Do you know really how to do
this. So you do activities.
I have no idea. That's really good. That was like a good go. My family's really pretty, so I also think that's my kind of grandma's sister. Yeah, I know.
Yeah, that's.
Especially on my dad's side. Okay, I don't think I have enough time to go over the entire problem, but this is very similar to lab 7. So before you go, I want to again emphasize, please try these out. Please try these out. If you have problems, questions, post it on Ed or come to my office hour. If I put it here. Okay, I'm trying my best. Do this.
Make more copies.
You guys have socials? outreach social, like there's a
Our side is, do you have the donut dates?
donut days. Donuts.
Like, they pair you with another committee member, you're supposed to have a little time to have those.
We don't have that, we haven't done any social. We have like 4 people that actually show up. Yeah. And we're already a friend group. Yeah.
It's. I guess. I
don't want to talk to, I don't want to talk to people. How many do people actually show up to your meetings? Like, you have like 10 people. You can do it. And,
we all have 2 meetings. Not the first one, there's like.
we had like 4.
And you bet you might do this too.
You should ask to do a survey in your community. And get those results. We had one on Sunday, it was fun. It was really fun.
I think the reason is
We're just stand your screen. And then we spit it out.
Failed.
It's only you for the while.
No, yeah. No, Taryn also is.
so this these are
But he left
that
that.
this one.
And then it was
This is
also. maybe
this
the-
is the-
Yeah, no one else came.
I appreciate.
This one is not the first.
Corey?
Now we started here, but some of it.
He did? Yeah. I didn't see that talking about like. I never did. Corey's like, yeah, So, he has a little paying attention.
Yeah.
I know, like.
Oh.
He's like, I don't know. I don't think it's gonna happen. I think they should just plan it to do it early next semester, when there's no.
I think they're too done around here. Paying attention. Just go.
Because they're just on first before. That's right. He can. Yeah. Nothing else you don't know. Is the only use. Really talk to us. It was funny, the guy that he rejected, he was like, I don't know this. Yeah, yeah. He's right. Yeah.
I couldn't rock with him, and I call it.
Yeah, I didn't like that.
Thanks.
It's the thing is version. I get it. But I can do that. But you're just me up with your. Oh, okay. Already from switching my vision. Very, very.